Boys and girls, here we go with video lesson 9-3 on hyperbolae. Hyperbolae, though they look very different from ellipses, they're very similar. So let's just take a quick look. If you remember, our equation for the ellipse looks like this. There's a big plus sign right there because we were adding two distances. And don't forget that h comma k is our center point. That A that you're looking at, very important. A is the distance from the center point to the edge. 2A is equal to our major axis. Our B goes from the center point to the edge the other way. That's B. This was A. 2B is our minor axis. And C goes from center to focus. This is 2C. That's a 2. And don't forget now, okay, that A, B, and C are related Pythagorically. B squared plus C squared is equal to A squared. The hyperbola is very similar, except that in this case, you can see the hyperbola is the difference of two distances from the focus, the foci, to our well, it's from the hyperbola, this distance and this distance right here. Those things will have a difference that is a constant. Okay. Also, still h comma k is our vertex, and a is the distance from center point to vertex. 2a is called our transverse axis. And the distance from the center point the other way, this distance and this distance, these are our B's. 2B is called our conjugate axis. And C is our distance from center point to focus. 2C, of course, is focus to focus. A, B, and C are once again related, but this time because C is our biggest distance, A squared plus B squared is equal to C squared. And let's play our favorite game. This game is called Name That Stuff. Here we go, here we go, here we go. Let's start by plotting our center point. Our center point is going to be at 0, 0 in this case, which means that h and k are both 0. Our foci are at -4, 0. And at 4, 0, that distance is our c. So c is equal to 4. This distance right here is our c. Our a is going to be at 2, so at 2, 0, and at -2, 0. That distance right there is A. And our B is found by doing A squared plus B squared is equal to C squared. So 2 squared, which is 4, plus B squared is equal to 4 squared, which is 16. So B squared is equal to 12. B is equal to 2 root 3, the square root of 12. So I'm just going to write that in here. Our A is equal to 2, and our B is equal to 2 root 3. That means that our transverse axis is 2A. That's equal to 4. And our conjugate axis is 2B, so that's equal to 4 root 3. Our equation is found, again, by doing x minus h squared over a squared minus, this time, y minus k squared over b squared, and all that is equal to 1. In this particular case, our h is 0, our k is 0, our a is 2, and our b is 2 root 3. So, our equation is going to be x squared over 2 squared, which is 4, minus y squared over 2 root 3 squared, which is 12, and that's equal to 1. Let me quickly get rid of some of our work. We'll get rid of that. Whoop, whoop. Alrighty. Lastly, we're going to find the slopes of our asymptotes. Actually, I'm going to draw in my conjugate axis as well. B was 2 root 3, which is about 3.5, because it was the square root of 12. So here's our conjugate axis, and I'm going to draw a little box. That's the length of both my transverse and conjugate axi. And that's going to help me draw in my asymptotes. The asymptotes are always going to have a slope of plus or minus b over a, or plus or minus a over b. It depends on which one is vertical and which one is horizontal. In this case, our b's were the vertical and our a's were the horizontal. So our slopes are going to be plus or minus 2 root 3 over 2, which of course equals plus or minus a slope of root 3. So I'm going to draw in my asymptotes. And now lastly, I'm just going to draw in my hyperbola, and we'll do that with a crayon. How's that sound? Starting at my vertex, I'm going to hug my asymptote. Starting here, hug my asymptote. Starting at the other vertex, hug my asymptote. Go down this way, and there we go. Don't forget to give your mom a big hug too. Alrighty, there's our first one. Isn't that pretty? Alright, let's go on to our second one here. Let's start by looking here, and we notice that this time our hyperbola is going to be vertical because the y is on the positive side and the x is on the negative side. Alright, we can look here. A, we can see is 4, and B is equal to 3. Our center point is going to be at negative 2, comma 4. So let's plot in our center point right now at negative 2, comma 4. We're going to have a vertical transverse axis with a length of 4 on each side. So we're going to go up here to our vertex and down here to our other vertex. A is going to equal 4. Our transverse axis is going to be a length of 3. So there's our B. Here's our other B with a total length of 3. Okay, so we can draw in our box right now. And I'm going to find my C, and I'm going to do that by using my A squared plus B squared is equal to C squared. A was 4, so 16. B was 3, so that's 9, and you can see right away that C is 5 because C squared is 25, and this is the 3, 4, 5 Pythagorean triple. So C is 5, which means now that let me write these in. So our center point was at negative 2, comma 4, and our foci are C away, which is 5. So up here and down here, because that distance right here is 5. So our foci are at the order pairs negative 2, comma 4 plus 5 is 9, and negative 2, comma 4 minus 5 is negative 1. Here are my two points. My transverse axis has a total length of 2a, which is 8. My conjugate axis has a total length of 2b, which is 6. And my asymptotes are going to have slopes of, in this case, a over b, because a was the vertical and b is the horizontal. So our slopes are plus or minus 4/3. Let's draw in our asymptotes. my first asymptote. Here's my second asymptote. And now just simply, let's draw in my hyperbola. We'll do that in purple. Starting here at my vertex. Here's the top half of my hyperbola, and here is my bottom half. Notice I'm once again plugging my asymptotes. Alrighty.